Professor H, and we're getting ready for our next experiment. And as you can see, we are in the kitchen. So first, a few general safety tips. Now, because we're in a kitchen, make sure you talk to your mom or dad before you do this experiment at home. It's very important. We are going to be using the stove, which is going to get very hot, and I don't want anyone to get burned. So make sure you talk to mom and dad. Make sure they're present with you when you do the experiment. So what we're going to talk about today is evaporation. Evaporation is when water disappears and goes into the air. Also, evaporation is part of the same process that water uses when it turns from a liquid into a gas or steam, which is really more what we're going to be doing. So we're going to be kind of showing evaporation, but we're also going to be making steam. Now, when does water turn into steam? Water goes from a liquid form to a gas form at 212 degrees Fahrenheit. That's the temperature scale we use in the United States. Or at 100 degrees Celsius. That's the temperature scale that scientists use in the United States and pretty much the rest of the world uses all the time. So don't ask me why they're different. That'll have to be another class. But for today, you just need to know if you normally use in Fahrenheit, which means 70 degrees is about room temperature, then you're going to be looking at 212 degrees Fahrenheit when water flashes to steam or turns to steam. The term flashes to steam is just another way to say it. Or you're going to be looking at 100 degrees Celsius. Okay, let's get started. Now, I've got my supplies out here. I've got some water. Doesn't matter if it's purified water or tap water. Just need some water. I've got a little measuring cup. Doesn't have to be a graduated cylinder or anything spectacular. Just a simple measuring cup like your mom or dad uses to make a cake is fine. I've got my spoon. Again, nothing special, just a stainless spoon. Very important item. Make sure you have a safety glove. Don't want you to get burned. Of course, you need a pot. Gotta have something to put the water in. Now this is optional. This is a lid, obviously. This is optional. I'm going to use this because it's going to make the process a little faster. But if you want to watch the water boil and mom and dad say it's okay, you can actually put the pot on. Don't put a lid. Stand at a safe distance. Look over it, and you'll actually start to see little bubbles form. And once those bubbles get to a certain point, they will actually pop or flash and turn to steam and float out of the pot. So, but we're not going to do that because, we have to do it for everybody. So, first thing we're going to do is pour our water in our cup. Now, I'm going to measure half a cup. Now, one of the neat things about water is it has something called surface tension. Surface tension is just a fancy way of saying water likes to stay together. So when you're measuring water in any kind of cup, you always want to measure. There's going to be a little curve, like a little U. And you always want to measure at the bottom of the U. Now, it's not saying that if you measure at the top of the U, it's wrong. That's just the way scientists measure. They always measure at the bottom. So I'm going to pour in half a cup. And there we go. And I'm going to walk this up to the camera so you can see that we have half a cup of water. All right. Now, I'm going to pour my water into my little pot. And I'm going to put the lid on my little pot. Don't need that just yet. I'm going to put my pot on the stove, and you notice the stove's red hot. I've been letting it heat. That's going to make it go a little faster. It's not going to take it very long at all. You hear all that noise. What you're hearing, all that noise, is actually a little bit of water already starting to pop into steam. That's how quick it can happen. If the surface is hot enough, the water could instantly turn into steam. When I was in the Navy, we made steam to make the ship go. That's right, we actually made steam exact same way we're doing it here. We didn't use a stove, we used a nuclear power plant. But it made the water really, really hot, and that hot water turned to steam. That steam was so strong that it came down a pipe, hit a turbine wheel, spun real fast, and actually drove a shaft out the back end of the boat and made the boat go forward in water. So that's really cool. You can do a lot of neat stuff with steam. The first cars were steam cars. Before they had gasoline, they used steam. Trains, locomotives, if you've ever watched old movies where they got the steam coming out the sides, that's what they're doing. They're using steam-driven pistons. So steam is an amazing force. I start hearing a lot of water boiling over here. So now whenever you open the pot on a pot, open the lid, on a pot, you can't open the pot, you gotta open the lid. Whenever you take the lid off of a pot that's been getting real hot like this one has, you want to be very careful that you aim the opening away from you because you don't want the steam to come out and get you because it will hurt. So I'm going to open it. Now I'm going to hold this up a little closer, and you're going to see steam rising right off of that lid. That stuff that looks like smoke is actually steam. And if you look inside, all those little bubbles or water that popped up onto the lid. So if you can see those little bubbles, that's the water popping up onto that lid. So that's actually steam. So now we've got a nice roiling boil. And now we're going to do the phase where you really need the mitt. I'm going to hold this spoon over this pot. I'm not going to go inside the pot. I'm not going to touch the water. But water is going to appear on this spoon. It's not magic, it's science. So I'm going to let the steam get there, and you'll notice it's getting foggy. Well, you probably can't see it, but when you do it at home, you'll notice your spoon gets foggy the same way your mirror gets foggy when you take a hot shower. It's the same principle. The water is condensing or gathering on the spoon. Now we're going to talk about condensation later, but for now just know that condensation is basically the reverse of evaporation. So, I've got lots of good water on my spoon. I'm going to bring it up close so you can see it at home. And you can see that steam rising off of it and all the water droplets there. This spoon just made water appear. So now we'll put the spoon to the side. We're going to turn off our boiling pot. And again, always be safety minded. That eye is very hot, so I'm going to let it cool off for just a moment. And then I'm going to take my mitt and hold my little measuring cup here. And I'm going to pour the water from the pot into the measuring cup, and then we're going to measure it and see if we really made water disappear or not. Now, does anyone remember? We had half a cup of water when we started, so now we're going to see how much water we got left. In science, when you do experiments, you have to make sure that you measure everything you do because someone wants to be able to reproduce it. If we were really going to be a good scientist, not only would we measure our water, but we would actually measure the temperature that our eye got to. But we know, because a lot of scientists have come before us, that it takes 212 degrees Fahrenheit or 100 degrees Celsius to make water turn into steam. So that wasn't part of our experiment. Whoa, listen to that noise. Alrighty, now we started at half a cup and we are definitely below half a cup. We're at about a third of a cup. I'm going to bring it up. I don't know if you'll be able to see it at home or not, but when you do it yourself you'll be able to tell. And we're right over a third of a cup. So we were at half a cup and now we have a third cup left. So we made water disappear. And if you want to know exactly how much, you can do the math and you can find out exactly how much 1/2 cup with only a third left leaves you. And when you do it at home, you're welcome to do that and figure out exactly how much. And if you want it to be less, you just let it boil a little longer and then the level will go back down. So that's it for our evaporation / turning water into steam, making water disappear experiment. And I'll see you later.